All right, this is an interesting example, and this is an example that illustrates why Bayes' theorem is interesting. Okay, and why Bayes' theorem is important. So let's take a look at this. A medical test has been designed to detect the presence of a certain disease. Among people who have the disease, the probability that the disease will be detected by this test is 93%. Okay, so if you have the disease, it will detect it 93% of the time. Okay. However, the probability that the test will erroneously indicate the presence of the disease in someone who does not actually have it is 5%. Okay, so 5% you get these false positives. All right, and it is estimated that 4% of the population who take this test have the disease. Okay, so this is a fairly rare disease. 4% of the population are being who are tested have possibly have this disease. So it's fairly rare. All right, so let's identify what are the stochastic events. What are those events of chance? So the events of chance are, first of all, the person who comes in to get the test either has the disease or they don't have the disease. Okay, so that's really the first event that where chance is involved. And we know that if just a random person comes in to take this test, they have a 4% chance of actually having the disease, which means they have a 96% chance of not having the disease. All right, so then we've got a person, let's say we have a person that has the disease. All right, I'm using D here in a couple different ways, having the disease or not. And also I'm going to use it for, this is probably not the best way to do it, but my second D here is actually, oh wait, no, that's not a D. Never mind. Hang on. I want to use a P. All right. So that person who comes in and gets tested is either going to test positive or they're not going to test positive. Could read my own writing. All right. Now, a person who doesn't have the disease is either going to test positive or not positive. Okay. Now, the probabilities are different, obviously. So if you have the disease, you have a 93% chance that this test will catch it and tell you correctly that, yes, you have the disease. But that means that 7% of people who have the disease will go undetected. So they'll get a false negative. If you don't have the disease, remember there's these false positives. So we have a 5% chance that there's going to be a false positive. You don't have the disease, but you tested positive, which means that there's a 95% chance that you don't have the disease. If you don't have the disease, you'll have a 95% chance that it will say, yes, you don't have the disease. Okay. All right. So now we want to know if a person comes in, tests positive, what's the probability that they actually have the disease? Okay. So that's the probability. Let me write it over here. Probability, we want to figure out the probability of having the disease given that you test positive. Oops. So let's look at all the ways that we could test positive. You could test positive in a couple different ways. Either you have the disease and you test positive, or you don't have the disease and you test positive. So what's the probability of having the disease and testing positive? Okay, we're gonna figure that out just by multiplying these probabilities. So if I take 0.04 times 0.93, so 0.04 times 0.93, and I got 0.0372. And then the probability of not having the disease and testing positive would be, again, so it is 96% chance, 0.96, that you would come in and get tested and not have the disease. And you have a 5% chance then, 5% of those people who come in without the disease will test positive, right? So that means 0.048. Okay, if I multiply that out. All right, so let's add those up. I'm just going to add those two probabilities together to get the probability of testing positive in general, right? You can do that a couple different ways. Either you have the disease or don't have the disease. So if I add those up, I get 0.0852. Okay. So now I want to calculate the probability of having the disease given that you test positive, right? That seems like an important thing to know. I come in for this test, I want to know what is actually the probability that if I test positive that I actually have the disease. All right, so it's going to be the probability of having the disease and testing positive over the probability of having the disease. Or sorry, I mean, I think I meant P. I can't tell my P's and my D's apart. So that's the probability of testing positive, right? So it's the second one. I'm interested in, what's the probability of testing positive, okay, which is the value I calculated right here. All right, so the probability of having the disease and testing positive is 0.0372. All right. And I want to divide by the total probability of actually testing positive, so 0.0852. If I put that into my calculator, you get an interesting result. Okay, here's what I get, 0.4366. So what's that saying? I came in to get tested for this disease, and I tested positive. But this is telling me that given that I tested positive, there's only a 43% chance, 43.66% chance that I actually have this disease, which is pretty interesting, not what you would expect, especially given that, there's 93% chance that if you do have the disease, right, that it'll give you a positive, that'll give you a detected, the disease will tell you that you are positive, right? But that is if you have the disease, right? And it will tell you. So given that you have the disease, it'll detect your disease 93% of the time. That's different from the probability of having the disease given that you test positive, right? It's kind of the flip of that. So it's pretty interesting. But let's take a look at the next part here. So now, let's say you get tested twice. Okay, so you test positive. If you test positive, you're maybe going to take it again, especially since this calculation is telling you that you really, given that you tested positive, you only have a 43% chance of actually having the disease. So you might want a second opinion, right? You might want to try it again. All right. So let's see what happens. Get this. We have the same data, right? A person comes in with that either has the disease or does not have the disease. Right? 4% chance that they have the disease. 96% chance that they do not have the disease. All right. Now the first test is either going to come out positive or not positive. And I'm going to call it positive 1 and positive 1 complement, right? So because it's the first test, we're actually going to test twice. All right. If you don't have the disease, it's either going to tell you a positive or a not positive, right? Okay. Now, if you test positive, you may want to get tested again. So if you tested positive, we're going to test you twice. So I'm going to call P2 testing positive on the second trial, the second test. So on that second trial, you're either going to test positive or not positive. Okay, but I'm just going to distinguish it as P2, meaning the second test. So again, we're only going to test if you tested positive, right? So we're only going to test twice, I guess, if you tested positive the first time. Okay, so on the second test, you're either going to be positive or not positive. Okay, so let's put in the numbers. There was a 93% chance that if you have the disease, it's going to catch it. Okay, which means 7%. I don't even really need to write that, but this should add up to 1. And then again, so we're this person came in, has a disease, they test again, but there's still a 93% chance. So given that they have the disease, there's a 93% chance that it will catch. You'll test positive. Okay. Now, if you don't have the disease, there's a 5% chance that you'll test positive, right? And the same way, if you test again, it's still going to be 5%. 5% chance that you'll test positive, okay? So we're looking for the events where you test positive twice, okay? You test positive twice. So here, let's say you test positive both times, right? So we're looking at this sequence of events where you test positive twice. And we want to know, given that the fact that you test positive twice, what's the probability now that you actually have the disease? So let's calculate, first of all, the probability of having the disease and testing positive on the first and testing positive on the second. Okay, you tested positive twice. Okay, I'm just going to multiply these probabilities, 0.04 times 0.93 times 0.93. And what I got was 0.0346. Okay, the other way that we could test positive twice would be in this event where you don't have the disease, but you tested positive once and you tested positive on the second trial, right? And I'm just going to multiply those probabilities, 0.96 times 0.05 times 0.05, which gives me 0.0024. Okay, if I add that up, that's going to give me the total probability of testing positive on both the first and second tests, right? So 0.036996 is what I got when I add those two numbers up. Okay, so what I want to know is the probability that I have the disease given that I test positive twice. Okay, so I'm going to indicate that by P1, positive 1, and positive 2. Positive on the first test and positive on the second test. Okay, so that's going to be the probability of having the disease and testing positive on the first and testing positive on the second over the probability of having two positive tests. Okay, so I'm just going to take those numbers. I got up here was the value for the probability of having the disease and testing positive on the first and testing positive on the second. So 0.0346 divided by the total probability of testing positive twice. So 0.036996. All right, put that in my calculator, and now it tells me 0.9351. Okay, so if I test positive twice, now I have a 93% chance of actually having the disease. Okay, now, there's still a, 6.5% chance that maybe you don't have the disease, but that's a lot better. I feel a little more confident if I test positive twice, right? There's 93% chance I had the disease. Whereas in the other case where I only tested positive once, it was less than a 50% chance that I actually had the disease. So that's a very interesting result. I'm going to put in a video, an optional video, in the lecture notes so that you can, if you want to know more about Bayes' theorem, it's kind of an interesting thing. All right, I've got one more example to go through, and I'll meet you in the next video.